Hello class, in this video I will be discussing module 2 lesson 2, which is related to motion in 2 or 3 dimensions. So if you remember the last video, it's about motion in a straight line. So uh, it's either X or horizontal motion or Y or vertical motion. So here it is a combination of 2 or 3 planes, which is XY or XYZ. Okay, so all of my discussion in this video will be based in the University Physics with Modern Physics 14th edition by Young and Friedman. Okay, so let us start. Position and velocity vectors. So since we are dealing here with 2 or 3 dimensions, it is important that we understand the vectors, kasi 'di ba ang vectors, doesn't only um, give us the magnitude or the value, it also give us the direction. Okay, so position vector, it is the position of a particular at a given instant. Okay, so it is represented as r vector equals x I plus yj plus zk. So if you remember, this representation is what we call unit vector. Okay, so the average velocity, it is a particular it is the velocity uh, of a particle during time interval from t1 to t2. So it is delta r over delta t. So kung mapapansin nyo, vector siya kasi nga we are very particular with the position, okay, or with the position or direction. So this average also dictates what is the position or the direction of the particle's velocity. Okay, so next, instantaneous velocity naman, ganun pa din. Is instantaneous velocity is the velocity of the particle at a certain point of time. So it is the change of r and t, change of r with respect to t when the change of time is approaching 0, or we can also represent that as the derivative of the position vector with respect to time, which has this representation. The x component of the velocity, instant velocity, is dx over dt. The y component would be dy over dt, and the z component would be dz over dt, or we can represent it as unit vector, and we can solve the magnitude, okay, through this, the square root of vx squared plus vy squared plus vz squared. Okay, so all of the lessons we discussed about vectors on the previous chapters or previous module will be applied here. Okay, so make sure that you know the basics of vectors very well. Okay, so next, ayan, let's apply this in example number 1. A robotic vehicle or rover is exploring the surface of Mars. The stationary Mars lander is the origin of coordinates, and the surrounding Martian surface lies in the xy plane. The rover, okay, not the river, it's the rover, which we represent as a point, has x and y coordinates that vary with time. Okay, ito yung x and the y coordinates. Okay, find the rover's coordinates and distance from the lander at 2 seconds. So what are we going to do here is just get the coordinate by using the function given. Okay, 2.0 meters minus 0.25 meter per second squared, and let's replace t by the 2 second. Okay, so let us compute 2 minus 0.25 times 2 seconds squared. Okay, that is 1. Okay, now let us check the significant figures. We have two significant figures, two significant figures, two significant figure. So two significant figure and one decimal point. So we just have to put it like 1.0 meter. Okay, so that is the x coordinate of the rover. So let us get the y coordinate. Meter per second cube times t cube. Ayan. So let us get it. 1 times, oops, let us replace t, I forgot. Let us replace t as 2 second. Okay. Same with here. Ayan. 2 plus 0.025 2 cube. Ayan. So the answer here is 2.2 meters. Now let us double check the significant figure. We have 2 here. 2. So 2 and 2 and then 1 decimal place. So tama. 2.2 meters. Okay. That is the x and y coordinate. Okay. And the distance. How do we get the distance? Okay. When we say distance, that is the magnitude. Okay. The magnitude of the rover. Okay? So, how do we get the magnitude? Diba? Meron tayong formula na x squared plus y squared. Okay? So, this distance is equivalent to 1.0 meter squared, 2.2 meter squared. So, the magnitude is plus 2.2. So we have here 2.4. Okay, 2.4 meters. Yan. Okay. Now, also we can represent its position, diba? Apply natin yung position vector. Okay. 1.0 meter I, this is the x component, plus 2.2 meter j. Ayan. Okay? So, that is the exact coordinate and the distance of the lander, the rover from the lander. Okay? Okay. Sige. Now, if you are going to observe, 'di ba? Nagdiretso tayo sa x squared plus y squared. Ang hinahanap here is the distance, okay? So dapat, 'di ba, when we say distance, meron tayong final position and the initial position. However, sabi kasi sa problem, let's just clarify things para hindi tayo magkalituhan. Okay. Sabi sa problem, the stationary Mars lander is the origin of coordinates. So, si lander daw is nandito. Okay, sa origin, sa 0, 0. Okay? Tama ba? Ayan. And then, si rover is merong given na x and y coordinate, which is here. Ito. With respect to time, kung ano yung time na yon is ibibigay nitong functions na to, okay? So, when we get the distance, ayan. Syempre, ang final position natin is yung sagot nitong x and y coordinate at 2 seconds, okay? And the coordinate 0, 0. So, ang distance formula natin, if you remember, diba? X final minus x initial squared plus y final minus y initial squared. Ayan, okay. Ngayon, shortcut natin, no? Kasi, sabi nga sa problem, kasi si lander is nasa origin. So, ang ginawa natin, slash out, ito na ay 0. Okay? So, ito na yung result niyan. Okay? I'm just clarifying things para hindi magkalituhan. Distance kasi yung hinahanap. Okay, distance. Okay. So, let's proceed. Sabi naman sa letter B, find the rover's displacement and average velocity vectors for the interval t equals 0 second and t is equals to 2 second. Okay. Find the displacement and average velocity. Okay. Ang hinahanap sa letter B is the displacement and average velocity. Yan. At t is equals to 0 second at saka t is equals to what? 2 seconds. Okay. Okay. Yan. So, pag makukuha natin yung displacement, diba, that is delta x. Okay? Delta r, delta x. We can get the displacement by delta r. Hindi na siya delta x ngayon kasi may y and y component na siya. Okay? So, this is r2 minus r1. Ang R1 natin is the position from 0.0 seconds. So, let us compute. Let's compute. Diba ang R1, we can represent that as x1 I plus y1 j. Okay. Ayusin natin ha. 2.0 meters. Ang x natin ay equivalent sa 2.0 meter minus 0.25 meter per second, and then second squared t squared, t time, okay, I plus yung y component natin, that is 1.0 meter per second, plus 0.025. Meron tong t2 ay t1, okay, 0.025 meter per second cube. This is t cube, t1 j. Okay, yan yung position vector natin at time 0 second. So, palitan natin to ng 0. Ito, pag naging 0 to, 0 na yan lahat. Pero meron siyang 2.0 meter na matitira. Okay. Tapos, ito, pag 0 yung time, ayan, lahat yan 0. So, plus 0.0 meter j. Ayan ang position vector natin ng R1. Ang R2 naman, nakuha na natin siya kanina. So, let's just represent it as vector. Ang R2 natin, ang x component natin here is, ayan, nakuha na natin 1.0 meter I plus 2.2 meter j. Okay. So, para makuha natin si displacement, we just have to subtract R2 from to R1. Ayan. So, let's subtract. Apply natin yung natutunan natin sa unit vectors. Ayan. So, R2 minus R1, 1.0 meter minus 2.0 meter I plus 2.2 meter minus 0.0 meter j. So, the displacement here is negative 1.0 meter I plus 2.2 meter j. Ayan, meron na tayong displacement. Yan. Okay. Now, we will get the average velocity. Pag kukunin natin yung average velocity, 'di ba? Ang average velocity is equivalent sa delta r over delta t. Okay? So, meron na tayo ditong delta r na result, 1.0 m I plus 2.2 mj, ayan, and then 2.2 second, ay sorry, ang T2 natin is 2.0 seconds minus 0.0 seconds. Okay? So, i-divide lang natin siya sa 2. So, that is negative 0.50 meter per second I plus 2.2 divided by 2 is 1.1. Ayan. 1.1 meter per second J. So, ito na yung average velocity niya. Okay. Yan. Yan na yung average velocity. Okay? So, yan lang naman yung kinukuha sa letter B. Okay. Now, displacement and average velocity. So, malamang kailangan natin ito ng magnitude. So, how do we get the magnitude? That is Vx squared plus Vy squared. Okay? So, negative 0.50 meter per second squared plus 1.1 meter per second squared. Ayan. So, let's calculate. Negative 0.50 squared plus 1.1 squared. That is equivalent to 1.2. Okay, that is equivalent to 1.2 meters per second. Okay, and kung kukunin yung direction, ayan, pag kukunin natin yung direction, diba, that is equivalent to tan negative 1 Vy over Vx. Okay, so kunin natin yung direction niya. Vy, that is 1.1 positive, and then negative 0.5. So, the answer is negative 65. Negative 65.6 degrees. Okay? So, kung ipa-plot natin yan, positive si y component, so nandito siya sa taas, and then negative si x, so nandito. So, si negative 65.6 is ito. Okay? Yan. So, ito yung direction niya. Ito yung direction nung velocity. So, ang sagot niyan is 1.2 meters per second. Ang velocity. The velocity is at 1.2 meter per second at 65.6 degrees north of west. Okay? Yan. Ganun nyo siya bibigyan ng direction. Okay? North of west. Now, okay na yan. Doon naman tayo sa letter C. Ayan. So, ang final answer dito, guys, is the vector. Pinakita lang natin kung paano kukunin yung magnitude. Pero the final answer here is y. Ma'am, bakit yan po yung final answer at hindi yung magnitude? Paano po namin malalaman kung vector po yung ibibigay namin at hindi yung magnitude. Ito kasi siya, guys. Final answer yan and this one. Ayan. Okay? Kasi, ang sabi niya here is, ang sabi niya dito is find the rover's displacement, and average velocity vectors. Ayan, vectors yung hinahanap. Okay? So, pag vectors, mag-unit vector kayo. Okay? So, letter C, find a general expression for the rover's instantaneous velocity vector V. So, hinahanap naman yung formula daw or yung expression or function ng the instantaneous velocity, which is equivalent to the change of r, velocity r over dt. Diba? Derivative. So, ang r natin ay equivalent sa, nakuha na natin, may formula na tayo kanina, hanapin lang natin. Ito. Ayan. 2 meters. Okay. 2.0 meters minus 0.25 meter per second squared t squared. This is I plus 1.0 meter 1.0 meter per second. Meter per second t plus 0.025 meter per second cube t cube. Okay. J. Ayan. So, ito yung velocity, position vector natin. And then, divided by dt. Okay. So, we have to derive that kasi that is the change of r over dt. So, let's derive para makuha natin si instantaneous velocity vector. So, ito, pag dinerive is constant. So, 0. So, magiging negative 2 times 0.25 meter per second squared t, okay, that is I, plus 1.0 meter per second, okay, plus 3 times 0.025 meter per second cube t squared j. Ayan. So, meron na tayong function or vector ng instantaneous velocity. Ito na yan. Ngayon, ang hinahanap natin here is ayan na, meron na tayong general expression. So, express V at t 2 seconds in component form and in terms of magnitude and direction. So, sa 2 seconds daw, ano yung velocity niya? Instantaneous velocity niya. So, palitan lang natin to ng 2 seconds. So, negative 2, 0.25 meter per second squared, 2.0 second, I, plus 1.0 meter per second, plus 3, 0.025 meter per second cube, 2.0 second squared, j, ayan. So, let us compute negative 2 times 0.25 times times 2. Ayan. So, here is negative 1. Negative 1.0 meter per second I plus 1 plus 3, 0.025 times 2 squared, that is 1.3. Okay. 1.3 meter per second. J. So, um, ito yung vector niya. Okay? Ito yung instantaneous velocity vector niya. Now, pinapakuha din yung magnitude. Okay? Pinapakuha din yung magnitude. So, we have to compute for the magnitude. Paano ba? So, V, diba, equivalent yan sa Vx squared plus Vy squared. Okay? So, square root of negative 1.0 meter per second squared plus 1.3 meter per second squared. So, ang magnitude niya is negative 1 squared plus 1.3 squared. That is 1.6. Okay. Meron siyang instantaneous velocity magnitude na 1.6 meters per second, but we have to compute for the direction. Okay. So that Vy 1.3 minus 0.1. Ay, sorry. Negative 1 pala. Okay. So the direction here is 1.3 over negative 1. So, negative 52.453. Okay. Negative degrees. Ayan. And, kung ipa-plot natin siya, may space pa dito. Kung ipa-plot natin siya, positive si y but negative si x, so dito siya banda. Okay. And then negative 52.43. So, ang velocity natin is 1.6 meter per second at 52.4 degrees north of west. Okay. So, ganyan. Okay. Now, so, yun lang. Tapos na si example number 1. Okay. So, let's proceed to the acceleration vector. When we say average acceleration, it is the average acceleration or the acceleration from the given interval t1 to t2. Ayan. Parehas lang din. Vector type lang siya. Okay. Ganun din sa instantaneous. Instantaneous acceleration is the particular acceleration at a given point of time. Ayan. So, dv over dt. So, meron tayong x, y, and z component ng acceleration, which is equivalent to the derivative of vx over dt, derivative of vy over dt, and derivative of vz over dt. So, we can represent it like this. Okay. And then, yeah, that's it. Okay. So, let's apply here as example number 2. Let's return to the motions of the Mars rover. In example 1, find the components of the average acceleration for the interval 0 to 2 seconds. O, ito naman. Balik tayo ulit sa given. Ang given kanina, may nakuha na tayong vector kanina, diba? Ito. I-copy lang natin. V is equivalent to negative 2 times 0.25 meter per second squared t. Ito is the I plus 1.0 meter per second plus tama ba? Let's check. T 1.0, okay. Plus 3 times 0.0 0.025 meter per second cube t squared. Ayan. This is J. Ayan. So, meron na tayong V. Ang hinahanap naman is the components of the average acceleration. So, kung matatandaan natin, si average acceleration is equivalent sa delta V over delta time. Okay? So, kunin muna natin si velocity at 0 seconds. Okay. So, palitan lang natin yung t ng 0. So, negative 2 times 0.25 meter per second squared times 0. Okay. I plus 1.0 meter per second plus 3 times 0.025 meter per second cube times 0 squared J. So, ito automatic 0. So, meron tayong 0.0 meter second I plus ito magiging 0 din. So, magiging 1.0 meter per second J. Ayan. So, kunin ulit natin yung velocity at 2.0 second. Okay. Alam ko nakuha na natin yan earlier. Check natin. Meron na tayong basis niyan. Ito. Ayan. Negative 1.0 meter per second plus 1.3J. Okay. Ayan. Negative 1.0 meter per second I plus 1.3 meter per second J. Ayan. So, hanapin natin yung average velocity by getting the delta V. Okay. Apply natin yung natutunan natin sa unit vectors. Ito yung V2 natin. So, negative 1.0 meter per second minus 0.0. Okay. I plus 1.3 meter per second minus 1.0 minus 1.0 meter per second J over okay. Ang delta time natin is 2.0 second minus 0.0 second. So, ang mangyari, ang average velocity natin is equivalent to average acceleration rather. This is average acceleration. Ayan. Mali pala. Acceleration. Ayan. Nalito-lito na. Ayan. Okay. Average acceleration is equivalent to what? Ayan. Negative 1 over 2 is negative 0.50 okay, meter per second squared plus 1.3 minus 1 k divided by 2 is 0.15 meter, ito ay meter per second squared J. Ayan. So, that is the average acceleration. Acceleration, guys, sorry. Nalito na. Okay. Acceleration. Acceleration is equivalent to delta V over delta T. Ayan. 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 So, ang sabi niya dyan, find the components. So, meron na tayong components. Okay. And, and we have to get okay, ang linaw lang natin na ang AX average component is negative 0.50 meter per second squared, and the average acceleration at Y component is equivalent to 0.15 meter per second squared. Okay. Now, let's go to the next. Find the instantaneous acceleration at 2 seconds. Okay. So, di ba, ang instantaneous acceleration is equivalent to dv over dt. Di ba? Now, meron tayo kanina. Di ba, meron na tayo nito. So, we just have to derive that. Ano na ulit yung vector na yan? Ito. Negative 2, 0.025. Negative 2, 0.25. Oops. 0.25 meter per second squared. Meter per second squared t I plus plus 1.0 meter per second plus 3 0.025 t squared. 0.025 meter per second cube t squared. Ayan. J. Okay. So, derive natin yan with respect to time. So, let's derive. Okay. So, ito malamang magiging negative 2 times 0.25 meter per second squared na lang. Let's get the calculator again. Yan. And then, plus, pag dinerive to, magiging 0 na to. Okay. And then, magiging 6 times 0.025 meter per second cube t. Ayan, J. Ito I. Okay. Now, we have the acceleration. Ayan. Meron na tayong acceleration vector. Anong gagawin natin? Kunin na natin. Ito yung instantaneous ha. Kunin na natin yung acceleration niya at 2 seconds. So, makukuha na natin yan. This is negative 0.25. Then, palitan lang natin to ng 2 seconds. This is I and this is J. Yan, negative 2 times 0.25. That is negative 0.5. Negative 0.50. Okay. I, meter per second squared, I, plus, oops, nawala. Okay. Plus, 6 times 0.025 times 2. 0.3 meter per second squared J. Ayan. So, meron na tayong acceleration at 2 seconds. Ito na yon. Ngayon, ang tinatanong ata is, ano ba tinatanong? Find the instantaneous acceleration at 2. Ito na. So, and hindi naman niya tinanong kung ano yung magnitude. So, pwede na to. Okay. Or we can get the magnitude din. Kunin natin yung magnitude. Paano natin kukunin? So, ax squared plus ay squared. Okay. So, a is square root of negative 0.50 meter per second squared plus 0.3 meter per second squared. Ayan. So, makukuha natin yung magnitude as 0.58. Yan. 0. Check natin yung significant figure ha. 2, 2. Okay. So, dapat 2 rin to. Yan. Okay. 0.58 meter per second squared. Ngayon, what is the direction? Importante guys na pag kinuha mo yung magnitude, dapat may direction din kasi vector ito. Inverse ng 0.3 over negative 0.50. Okay. Over negative 0.5. Okay. That is negative 30.9 degrees. Ayan. So, tingnan natin. Positive si x, ay negative si x, positive si y. So, dito siya banda ulit. Okay. So, ang acceleration niya is the acceleration is 0.58 meter per second squared at 30.9 or pwede ng 31 degrees north of west. Okay? So, ganun lang siya. So, next, ayan. So, sa acceleration, meron tayong tinatawag na parallel component at saka perpendicular component. Ayan. So, ang acceleration pala, ito yung acceleration vector mo, meron siyang parallel component at saka perpendicular component. Ito si perpendicular. Okay? Ang perpendicular component, it tells us about the change in particles direction. Direction of motion. Okay? Direction lang. Kung nagbabago ba yung direction niya. Now, kapag sinabi mong parallel, kaya parallel kasi parallel siya dun sa speed or dun sa velocity vector. Ngayon, pag parallel component of acceleration, it tells us about the changes in the particle speed. Okay? Ang parallel sa particle speed, change in particle speed. Ang perpendicular component ng acceleration is change in the direction of motion. Okay? So, ganun lang. And, kasama rin sa 2D or 3D motion is the projectile. Okay? Pag sinabi nating projectile, it is any body that is given an initial velocity and then follows a path determined entirely by the effects of gravitational acceleration and air resistance. So, ito ay trajectory. For example, nagtapon ka or naghagis ka, okay? Tapon mo pataas, pero automatically bababa din siya, okay? Kahit gaano pa kataas mo itapon yan, dahil sa gravity, babagsak at babagsak pa din, okay? So, ang acceleration na pinag-uusapan natin dito is the gravity, which is 9.8 meter per second squared sa SI and 32.2 feet per second squared. 32.2. Okay, 32.2 feet per second squared sa English. Now, meron tayong acceleration vertical pero wala tayong acceleration pa ganito. Okay? Zero acceleration tayo dito. Now, pag sinabi mong zero acceleration pa horizontal, ibig sabihin, ang velocity x natin is constant kasi wala nga siyang acceleration eh. Pero, ang Vy natin is varying. Depende dun sa gravity. Okay? So, yan yung trajectory natin. So, ito yung example. Ayan o. Kung mapapansin nyo, yung x component hindi nagbabago. Okay? Parehas lang sila. Pero yung y, nagbabago siya kasi nagbabago ng direction. Okay? And, ang acceleration lang natin is only the gravitational force. Pag dito, ito yung H max or the maximum height reach. Pag nandyan ka, ibig sabihin, ang velocity mo, velocity y mo ay 0 na. Why? Kasi if you remember sa free falling bodies, 'di ba? Free falling bodies, dun siya sa point na wala na siyang velocity pataas, mahuhulog na lang siya, 'di ba? Zero effort, yun nga yung sinasabi natin, zero effort, basta-basta na lang mahuhulog, okay? So, eto namang range, pag sinabi mo namang horizontal range, eto yon, the maximum distance hanggang mahulog pababa si particle. Okay? Matapos mong ihagis, babalik din pababa. Yun yung tinatawag na range. Okay? So, yan lang yung kailangan nating tandaan. Okay? Sa projectile. And, syempre, applicable pa rin dito yung mga formulas natin before. Okay? Yung, di ba may formula tayong x is equals to x0 plus VOT plus 1/2 AT squared, sorry. 1/2 AT squared. Pag x ang pinag-uusapan natin, okay, automatic ito, gawin nating 0 yan. Okay. So, ang VO natin dito malamang is VO cosine theta. Why? Kasi, di ba, ang velocity natin dito is may angle. So, kunin lang natin yung x component niya. That is cosine theta. Okay? Vx over v. Kaya, magiging VO cosine theta. Initial velocity to ha. Times time. And then, if you remember, I said earlier na wala tayong horizontal acceleration. So, ito 0 na. So, ito na lang yung formula ng x component. Ayan. Diyan siya nakuha. And then, kapag y naman, ganun pa din. Y0 plus VOYT plus 1/2 AT squared. Okay? So, y, let's say 0 ito, ang initial distance, vertical distance. Ang VOY natin is VO sine theta t. And then, acceleration natin, meron, that is the gravity, which is negative 1/2, negative 9.8, okay, meter per second squared, okay? Or, safe natin, lagay na lang natin G, kasi, baka English, so G na lang, negative 1/2 G t squared. So, dun nang galing itong formula na to, okay? Next, sa velocity naman, di ba meron tayong formula sa kinematics na V is equals to V0 plus AT. Tama? And, sinabi natin kanina na ang horizontal kasi ito yung Vx, ay walang acceleration, so 0. So, ang Vx mo ay equivalent lang ulit sa V0 cosine theta. Okay? So, constant siya. So, kahit saang point ng projectile, ang Vx mo ay V0 cosine theta. And now, ang Vy, yan yung nagbabago. VO0 plus 80. Okay? Vy, so, ang VOY natin dito is V0 sine theta. At ang acceleration natin ay negative G times T. So, dito siya nanggaling. Okay? So, ayan yung formulas natin. And then, let's apply that in this example. Ayan. Example number 3, a motorcycle stunt rider rides off the edge of a cliff. Just at the edge, his velocity is horizontal with magnitude 9.0 meter per second. Find the motorcycle's position, distance from the edge of the cliff, and velocity 0.50 seconds after it leaves the cliff, the edge of the cliff. Okay, so halimbawa, ito si cliff. Okay. Ito si motorcycle. Sabi niya, just as the edge, his velocity is horizontal lang. Okay, wala siyang vertical. So, horizontal velocity lang na 9.0 meter per second. Yan yung VO, initial velocity niya. Find the motorcycle's position distance from the edge of the cliff and velocity 0.50 seconds after it leaves the edge of the cliff. Hinahanap nating time ay 0.50 seconds. Ang hinahanap dito is the distance and the velocity. Okay. So, kung ang datum natin is si motorcycle, yung una niya, 00 yan. 0, 0 ha. Datum. Yan. So, makukuha natin si distance, 'di ba? Meron tayong formula earlier na x xo plus vot. Okay? Wala tayong acceleration, 'di ba? Ito yung formula. 1/2 gt squared, pero wala tayong acceleration sa x. So, ito lang siya, vot. So, ang x natin dito is 9.0 meter per second. Wala ring angle kasi horizontal lang siya. Times time na 0.50 seconds. Okay? 9 times 0.5, that is 4.5 meters. Now, let's proceed to y. Okay? So, palitan lang natin to ng voyt, and then 1/2 gt squared. Ngayon, di ba may formula tayo na yun nga, yo plus voyt plus 1/2 at squared. Ayan. Pero wala tayong vertical velocity, so 0. 0 din yung yo natin kasi ang datum natin ay nasa 0, 0. So, ang formula na lang natin dyan is negative 1/2 gt squared, which is 9.8, 0.5 seconds. So, ito ay meter per second squared. So, let's compute. Negative 1/2, okay, 9.8.5 squared. So, ang y natin ay nasa negative 1.23. Okay. Check natin. 2. Okay. Negative 1.2 meters. Okay. Now, distance from the cliff. Ito yung x coordinate natin and the y coordinate. Okay? So, distance yung hinahanap. So, dapat magnitude ang ibibigay natin. Distance is equivalent sa, diba, x final minus x initial squared plus y final minus y initial squared. Distance formula yan. Okay? Ang x natin na initial and y initial is 0. So, automatically, that is 4.5 meter squared plus negative 1.2 meter squared. 4.5 squared plus 1.2 squared. Okay? That is 4.7, yeah. Distance is 4.7 meters from the coordinate, or we can have the position vector na 4.5 meter I minus 1.2 meter J. Ayan. We can have that. Okay? So, next, or we can get the angle pala of direction. So, that is the inverse of negative 1.2 over 4.5. Okay. Kunin natin yung angle. Negative 1.2 over 4.5. Negative 14.93. So, kung ipa-plot natin siya, ayan. Ito si motorcycle. Okay. Positive si x, but negative si y. So, nandito siya. Okay. Ito yung position niya. Okay. Negative 14.93, or the position is 4.7, the distance is 4.7 meters, 14.93 degrees below the horizontal axis. Okay. So, yan. Pwede yan. Okay? So, next, meron na tayo ng distance. So, let's go to the velocity. And velocity, 50 seconds. Oh, ang hinahanap dito yung instantaneous velocity kasi wala namang time interval. So, ang velocity niya at 0 point, ano na yung time na given? 50 seconds. Okay, 0.50 seconds. So, hinahanap yung instantaneous. Ang meron tayo as of now is itong position 4.5 mi minus 1.2. Okay, meron tayo nito 4.5 mi minus 1.2 mg. At alam natin na ang instantaneous velocity ay equivalent sa dr over dt. So, let's just ayan. Okay. So, pwede rin yan dahil hindi naman to function. Okay. Meron tayong formula na Vx is equivalent to V0 cosine theta, diba? And Vy as VO sine theta minus GT. Okay? So, ito, dahil constant naman to, ito yung 9.0 meter per second. Tama ba? Kasi ang theta natin dito is 0. Okay? Yan yung initial ng velocity natin. Wala tayong y component ng velocity, initial velocity. Ang meron lang tayo negative gt is negative 9.8 times 0.50 seconds. Okay? So, ang Vx natin at Vy ay 9.0 meters per second at ang Vy natin is equivalent sa negative 9.8 times 0.5. So, yan. Negative 4.9 meters per second. So, kung gagawa tayo ng vector niyan is that is 9.0 meter per second I minus 4.9 meter per second J. Okay? So, kung kukunin natin yung velocity, okay, kunin natin yung magnitude, 9.0 squared plus negative 4.9 squared. Ang velocity natin dyan ay 9 squared plus 4.9 squared 10.2. Okay. 10.2 meter per second at what direction? Inverse tangent ng negative 4.9 over 9. Okay, get natin yung direction. Negative 28.56. Kung ipa-plot natin ulit, andito si motorist. Positive yung x niya but negative yung y. So, nandito siya. Ito si velocity. Ayan. Okay. So, ang velocity natin is 10.2 meters per second, 28.56 degrees below the horizontal. Ayan. Okay. So, that's how we can solve. Okay. That's how we can solve example number 3. Okay. Let's proceed to the next example. A batter hits a baseball so that it leaves the bat at speed Ayan. Meron ng angle. 37 meters per second na initial velocity with an angle of 53.1. Find the position of the ball and its velocity, magnitude, and direction. Okay. At 2 seconds. Find the time when the ball reaches the highest point of its flight and its height. Okay. So, sa letter A muna tayo. May given tayo na 37.0 meter per second at angle na 53.1 degrees. Okay. So, kung idodrawing natin, ito si baseball. Ayan. Pinalo siya ng okay, 37.0 meter per second at 53.1 degrees. Okay? So, hinahanap is yung, sa A, ang hinahanap is yung position at saka yung velocity niya at 2.0 second. So, position, meron tayong x is equals to ito na lang yung 0, 0 natin ha. Okay. Meron tayong x na x0 plus VOT. Okay. VO cosine theta t. Walang acceleration. So, ito 0. So, x is equals to 37.0 cosine 53.1 degrees times time na 2.0 second. Okay? 37 cosine 53.1 times 2. So, that is equivalent to 44.4. So, multiply to, dapat 3, 2, okay, so dapat 44. Okay, 44 meters. Okay. Tama ba? Hindi. 2.00 seconds pala. So, 3 significant figures. So, 44.4 meters. Now, let's solve the y. Okay. So, y0 plus VO sine theta t. Okay, minus 1 half gt squared. Formula yan ha. Y is equals to, ito 0 na. So, 37 sine 53.1. Okay. Times time na 2 seconds minus 1 half 9.8. T squared is 2.00 squared. Okay. So, ang y natin is 37 sine 53.1 times 2 minus 1 half 9.8 and then 2 squared. Ayan. So, ang y natin here is 39.6 meters. Okay. That is the position. So, kung isusulat natin siya as position vector, dito natin ituloy. Ang sagot is 44.4 meter I plus 39.6 meter J. Ayan. Okay? So, solve na tayo sa position. Let's go to the velocity. Okay, let's go to the velocity. Vx natin is V0 cosine theta. Okay? Ang Vy natin is V0 sine theta minus gt. So, ito ay 37.0 cosine 53.1. Okay? Ito ay 37.0 sine 53.1 minus 9.8 meter per second squared times ilang seconds yon? 2. Okay? So, compute natin 37 cosine 53.1 22.8 meters per second. Ang y naman natin is 37 sine 53.1 times 2 minus 9.8 times 2. Ang y natin ay 39.6. Tama ba? 37 sine 53 point. Ay, wala palang t doon. Okay, sorry. Okay, yan lang pala. Okay. 9.9 or pwede na natin siyang isulat as 10.0 meters per second. Okay. Or 9.99 para masakto. 9.99 natin. Kasi kung i-check natin yung significant figure, ito is 2.00. Okay. Ito, 2 significant figure. Ito is 3 significant figure, isang decimal place. So 10.0 pala talaga. 10.0 meter per second. Kasi 1 decimal place lang. Okay. Next, kung isusulat natin yung v niya as unit vector, that is 22.2 meters per second plus 10.0 meters per second j. Ayan. So, ano ba ang magnitude? Pag kunin na natin yung magnitude, that is vx squared plus vy squared. (22.2 squared plus 10 squared). Okay. That is 24.3 meters per second. Sulat natin 22.2 squared plus 10 squared. Okay? Now, we need the direction. Okay? Huwag kakalimutan yung direction. 10 over 22.2. Okay? That is inverse of 10 over 22.2. So that is 24. Okay. 24.2 degrees. Okay. So, positive. So, ibig sabihin, nandito lang siya. So, ang sagot dyan, ang velocity natin is 24.3 meters per second at 24.2 degrees above the horizontal. Okay. So, ganon. Okay. Next, meron pa bang letter C? Okay, meron letter B pa pala. Okay. Find the time when the ball reaches the highest point of its flight and its height at this time. Highest point. So, kung ito yung projectile, ano daw to? Yung highest. Find ano yung pinapahanap? The time at saka yung height. Height at saka yung time kung kailan niya ma-reach tong highest point. Pero 'di ba sabi natin kanina, pag nasa highest point, ang Vy niya ay 0. So madali na lang 'yan. Okay? So set lang natin, gamitin natin tong formula na to. Vo sin theta minus gt. Set natin to as 0. So Vo is 37.0 sin 53.1 degrees minus 9.8 times time. Okay, hinahanap yung time. So, 0 equals 37 sin 53.1 minus 9.8 alpha x, then shift solve. Ang x natin ay nasa 3.02. Okay? So, 3.02 seconds. Okay? Now, ayan na. Okay. Mm, or pwede na natin siyang i-3 seconds. Okay? I-3 seconds na lang natin kasi kung titignan natin, ito, hindi, 3.02 pala. Kasi ang gamit nila sa time is 3 decimal. 3 significant figures. So, time, ayan na. Ito na yung, oops, bakit nabura? 3.02 seconds. Ito na yung sagot dyan sa isa. So, yung height naman, we can solve it by y0 plus VO sine theta t minus 1/2 gt squared given na 0 yung initial. So, y is equals to 37.0 sine 53.1 times 3.02 seconds minus 1/2 9.8 3.02 seconds squared. Okay? So, kunin natin yan. 37 sine 53.1 times 3.02 minus 1/2 9.8 3.02 squared. Okay. 44.7. Okay. Ang height natin here is, or yung y, is y max. Okay. 44.7 meters. Ayan. So, that is the final answer for letter B. So, let's proceed to letter C. Find the horizontal range. That is the horizontal distance from starting point to where the ball hits the ground and the ball's velocity before it hits the ground. So, ang hinahanap naman dito na lang tayo sa gilid. Yan. Diba kung ito yung bola, yan. Hinahanap is yung, isin natin yung drawing. Oops. Ayan. Ito yung hinahanap, yung range. Okay. And then, yung velocity niya before it hits the ground. Okay? So, first, need nating malaman kung anong oras, diba? Kasi, magagamit natin yan, yung x is equals to x0 plus v0 cosine theta t. Okay. Kaso, hindi natin alam yung time. Ang pwede lang natin gamitin is, kung mapapansin nyo guys, pag bumagsak yung bola, ibig sabihin na ang height niya is 0 ulit, diba? So, pwede natin gamitin to. VO sine theta t minus 1/2 gt squared. Okay. 0 to at 0 din to. Okay. Kumbaga, ang initial position natin ay 0 at ang final position natin ay 0. When it terms sa height lang. Okay. So, 0 is equals to VO is 37.0 sine 53.1 t minus 1/2 9.8 t squared. Ngayon, dahil ito ay quadratic equation, mas madaling gamitin kung dito tayo sa equation. Ayan. Tapos, in this format, okay, 3. So, negative, yung squared muna, negative 1/2 9.8. Okay. And then, next is 37 sine 53.1. And then, C is 0. Okay. So, ilalabas niya dalawang values, which is 6.04 seconds at saka 0 seconds. Okay. Tama naman guys, kasi at 0 seconds, nasa 0 siya. So, after 6.04 seconds, bumagsak na ulit siya sa lupa. Okay. So, meron na tayong ilalagay sa time dito. So, x is equals to 37.0 sine cosine 53.1 times 6.04 seconds. Okay. So, mode 1. Okay, balik tayo. 37 cosine 53.1 times 6.04. So, ang range pala natin is nasa 134. Okay. 3 significant figures lang tayo. So, 134. Now, hinahanap yung velocity. Okay. Diba may formula tayo dito na Vx is equals to V0 cosine theta at saka Vy V0 sine theta minus gt. Okay? Etong Vx natin, constant yan. So, 37. Sulat na lang natin. 37 cosine 53.1. Ito naman is 37 sine 53.1 minus 9.8 times 6.04. Okay. So, ang Vx at Vy natin ay equivalent sa 37 cos 53.1, 22.2 meters per second, tsaka 37 sine 53.1 minus 9.8 times 6.04, negative 29.6 meters per second. Okay? So, pag isusulat natin si velocity as a vector, that is 22.2 meters per second I minus 29.6 meter per second J. Okay? And, kung kukunin natin si magnitude, okay, magnitude 22.2 meters per second plus squared plus negative 29.6 meter per second squared. Okay. So, ang magnitude natin sa velocity ay 22.2 squared plus negative 29.6 squared, 37. Okay. Meters per second. Okay. So, tingnan natin. Tama ba? Ano bang tinatanong? What was the question? Ball's velocity before it hits the ground. Okay. So, ayan. So, ang velocity niya before it hits the ground ay nasa around 37 meters per second pa din. Okay. Ang direction na lang niya is negative 29.6 over 22.2. Negative 53 point negative 53.13 negative 53.1 degrees pa din. Okay? Pababa naman na siya. So, kung ipa-plot natin positive positive x negative. So, ganyan siya. Ayan. Pababa naman. Okay? So, ayan. Ayan, ganyan, that's how you solve. Pwede na tong final. Actually, pwede na tong final. Okay. Final answer, okay? So, next, let's solve example number 5. Yan. You throw a ball from your window 8 meters above the ground. Okay. When the ball leaves your hand, it is moving at 10 meters per second at an angle of 20 degrees below the horizontal. How far horizontally from your window will the ball hit the ground? Ignore air resistance. So, halimbawa, 8 meters above the ground. So, nasa building ka. Okay. Let's say, nandito ka. Ito yung window mo. Okay. 8 meters. Okay. Ang datum natin, ito na lang. Ito na lang. Andito yung 0 natin. Okay? So, nagtapon ka daw ng bola. 10 meters per second at 20 degrees angle. So, malamang pag nagtapon ka, mahuhulog siya pababa. Ang hinahanap is how far horizontally. So, ito. Yung range yung hinahanap. From your window will the ball hit the ground. Okay? So, pwede natin gamitin dyan is y0 plus voyt minus 1 half gt squared at saka yung x0 plus voxt. Ayan. Okay. So, kung ang 0 natin ito, okay, hanapin muna natin yung time kasi ito yung range. Okay, ito yung range. Kaso wala tayong time, so we have to find the time. Ang initial natin is 0 kasi ito yung datum natin. Ang final natin is negative 8 kasi pababa, okay? So, negative 8 is equals to 0 plus VO is 10.0 sine 20 degrees, okay? 20 degrees below the horizontal. So, mali pala yung aking direction dito. Kung ito yan, kung ito si window, 20 degrees below the horizontal ka, nagtapon. Pag ganyan pala yung tapon mo. So, mali pala tong drawing natin. Okay. Ulitin natin si drawing. Okay. Kung ito si building, andito si window. For example, ito si window. Ito yung datum natin, 0. Nagtapon ka ng bola 20 degrees pababa at 10 meters per second. So, mahuhulog siya pa ganyan. Okay? So, ang range natin ganyan. Yan. Yan yung tamang drawing. Okay? So, pag i-compute natin siya, negative 8. Okay? Kasi pababa, ito ay 8 meters. Ito yung datum ha. Ito yung 0, 0. Okay. Negative 8 is equals to 0 plus ang VO natin is 10.0. Okay. Sine. Look at this guys. Dahil 20 degrees pababa at rotating clockwise siya, dapat negative 20 to. Yan. Times t minus 1 half 9.8 t squared. Okay. So, parang kanina lang din. Lipat natin to. Gawin nating negative 1 half 9.8 t squared plus 10 sine negative 20 t plus 8 equals to 0. So, gamitin natin si quadratic equation to find the roots. Okay. Negative 1 half times 9.8 okay equals 10 sine negative 20 plus 8. Ayan. So, meron tayong time na 0.98 seconds at saka negative 1.67. So, since ang hinanap natin dito ay time, so hindi na natin to i-consider kasi mali siya. So, ito lang. Okay? Yung 0.98. So, ibig sabihin, at 0.98 seconds, nakalapag na si bola sa floor. Okay, or the ground. So, makukuha na natin si range na x0 plus VO cosine theta t x. Ito ay 0. So, ang VO natin ay 10.0 meters per second cosine negative 20 degrees at 0.98 seconds. Okay. So, ito na yung range natin. 10 cosine negative 20 times 0.98. 9.2. Okay. Ang distance natin from the ground is from that window horizontal is 9.2 meters. Yan. Okay. So, ano pa? How far? Yun lang naman yung tanong. So, solve na tayo sa example number 5. So, next topic tayo, motion in a circular motion. Ayan. Meron tayong dalawa actually. Uniform circular motion saka non-uniform circular motion. So, uniform circular motion, when a particle moves in a circle with constant speed, the motion is called uniform circular motion. So, kapag constant speed tayo, ibig sabihin, di ba kanina nabanggit ko ang acceleration natin nandito banda, di ba? Okay, acceleration nandyan banda. Now, meron tayong tinatawag na parallel acceleration at saka perpendicular acceleration, di ba? Mali. Okay. Yung perpendicular, okay. Yung perpendicular acceleration, it refers to the acceleration with regards to the change in direction. Okay. Yung parallel acceleration, it regards to the change in speed. Okay. Pag sinabi nating uniform circular motion, ibig sabihin at constant speed siya, uniform nga eh. So, ibig sabihin, ang parallel acceleration niya ay equivalent sa 0. Kaya, ang nangyayari, pag kinuha mo yung acceleration in a motion in a circle at uniform circular motion siya, ang magkakaroon lang tayo is the perpendicular acceleration or the ARAD, ayan, the magnitude of acceleration of a particle in uniform circular motion that is equivalent to v squared over r, which r is the radius of the object sa circular path and v is the speed of the object. Okay? Pwede rin natin siyang i-compute as period of motion, 4 pi r squared r over t. Okay? So, formulas. And, ayan. Sige, try natin dito. An Aston Martin V8 vintage sports car has lateral acceleration of 0.96 g. Okay. Ayan, 9.4 meter per second. This is the maximum centripetal acceleration the car can sustain without skidding out of a curved path. If the car is traveling at constant speed of 40 meters per second, okay, on level ground, what is the radius of the tightest and bank curve it can negotiate? What is the radius of the tightest bank and bank curve it can negotiate? Kung ito yung acceleration niya, binigay na niya yung acceleration na ARAD. Okay. 9.4 meter per second squared. Ano daw yung radius? Okay. So, malamang 9.4 meters per second equals sa 40 meters per second squared over the radius. So, ang radius natin is equivalent sa 40 meters per second squared over 9.4 meters per second. So, let's compute 40 squared over 9.4. Yan. Equivalent sa 170 meter radius. Okay? So, ganun lang kasimple si example number 7. And then let's proceed to example number 8. Passengers on a carnival move at a constant speed in a horizontal circle of radius 5 meters, making a complete circle in 4 seconds. What is their acceleration? O, paano mo malalaman na, ano siya, na, paano mo malalaman na, uniform circular motion siya? Kasi etong constant speed. Ayan. So, hinahanap niyan acceleration, malamang yung acceleration na a rad, okay? V squared over r, okay? A rad equivalent sa V squared na okay, making a complete circle in 4 seconds, okay? So, hindi niya binigay yung velocity, 'di ba? Hindi niya binigay yung velocity, pero pwede natin siyang i-compute dun sa 4 pi r squared over t. Tama ba? Yung formula kanina. Ayan. Ay, 4 pi squared pala. 4 pi squared r t squared. Oops. Kasi binigay niya yung period eh. Kasi ang period, 'di ba, is the time to complete a complete circle. 4 pi squared r t squared. Ayan. So, 4 pi squared times r na 5.0 meters times 4.0 seconds. So, that is 4 pi squared 5 times 4 squared. So, ang sagot dyan is 12. Okay, let's check for 12.3 meters. Meters per second squared. Okay, yan yung final answer. Okay, so let's proceed to the motion in a circle, non-uniform. Pag sinabi naman nating non-uniform, ibig sabihin yung speed niya nagva-vary. Okay? Kaya nga siya non-uniform. So, magkakaroon na tayo ng parallel acceleration, or ang tawag dito is tangent, kasi nakatangent siya sa velocity vector. Okay? So, magkakaroon na tayo ng dalawang component, this one at saka this one. So, dv over dt, or the acceleration is equivalent sa magnitude is a rad squared plus a tan squared. Okay? So, yon. So, ayun, ganun lang yung formula niya. Parang ganito rin siya, guys, pero magkakaroon tayo ng etong isang component na to. Okay? So, let's proceed to the relative velocity. Okay? This is the last for this video. Relative velocity. Pag sinabi natin relative velocity, it is the velocity seen by a particular observer. So, halimbawa, ayan formula is Vp with respect to A is equals to Vp with respect to B plus Vp with respect to A. Okay? So, ganun din in 2 or 3 dimension. Okay? Vector nga lang siya. So, for example, meron tayong, halimbawa, ito ay sasakyan. Okay? Yan. Tapos, sa sasakyan may passenger. Yan. So, ito yung P. Ito yung B. Tapos, meron tayong observer dito na A. Constant siya, hindi siya gumagalaw, or at zero motion siya. Zero speed, okay? Now, para makuha mo yung velocity ni passenger with respect to the observer, ito yung formula niya. Velocity nung hinahanap mo with respect to a stationary observer is equivalent sa velocity nung particle or nung passenger with respect dun sa kasama niyang nakasakay o sinasakyan niya, plus velocity of the bus with respect ulit dun sa stationary. Yan. Yan yung formula. Okay? Ganon din dito. Ito nga lang merong x and y or z component. Okay? So, let's try that in the example. Okay? You drive north on a straight 2-lane road at a constant 88 km/h. Okay. So, drawing natin. Yan. You drive north. O, halimbawa, nandito ka. Nagde-drive ka. O, ikaw to. Yan. Let's say, U is Y. Let's set it like that. Going to north. Okay? So, going to north, ibig sabihin, positive tayo. A truck in the other lane. So, other lane, okay? Kasi 2-lane road yan. Approaches you. Approaches you. So, ang direction niya pa south. Ito si truck. Okay. 104 km per hour. Ang direction niya negative is kasi going south. Ikaw positive kasi going north ka. Positive 88 km per hour. Find the velocity, find the truck's velocity relative to you. Find the truck's velocity relative to you. Okay? Now, kung mapapansin nyo, wala siyang binigay na stationary observer. So, let's put a stationary observer sa surface ng Earth or nasa labas, hindi gumagalaw. Okay? So, gawin natin siyang E. Okay? So, di ba ang formula dyan is yung hinahanap mo relative dun sa stationary observer, yung equals yung hinahanap mong velocity with regards or relative to kung saan siya nakasakay. Okay? And then, yung hinahanap mo with regards to the relative observer. So, ang formula natin is, ang hinahanap natin is the truck relative to you. Okay? Velocity of the truck with regards to the stationary observer muna equals velocity of the truck with regards dun sa relative to you, etong hinahanap, ayan, plus velocity mo with regards to the stationary observer. Okay? So, ganun siya. Yung velocity na hinahanap mo with regards to the stationary observer, yung velocity na hinahanap mo with regards to the other particle, which is u, plus velocity nung other particle with regards to the observer. So, ang hinahanap mo is velocity of the truck relative to you. So, ito yon. Yan yung hinahanap. So, ayusin natin. Vty is equals to Vte minus Vye. Okay? So, Vty is equivalent. So, yung truck with respect to the Earth is, or the Earth, sabi niya is 104. Negative kasi going south kilometer per hour. Okay. Minus Vy, yung speed mo with relative to the stationary observer, which is positive 88 kilometer per hour. Okay. So, ayan. Ang sagot natin dyan is negative 104 minus 88. Negative 192 kilometer per hour. Okay. Yan yung speed nung kotse, ay nung truck relative to you. Okay. Ang tingin mo dyan is, ang speed niya is negative 192 kilometer per hour. Okay. Now, hanapin mo rin daw yung your velocity relative to the truck. Okay, your velocity relative to the truck. So, ang hinahanap naman is your velocity relative to the truck. Okay. Your velocity, ay, sorry. Okay, ang hinahanap natin is your velocity relative to the truck. So, kailangan your velocity relative to the stationary observer, velocity relative to the other particle, plus velocity of the other particle relative to the stationary. Okay? So, ang hinahanap mo is your velocity relative to the track. Ito. So, Vyt is equals to Vye minus Vte. Okay? So, ang velocity with regards to the stationary observer is 88 positive kilometer per hour. And then, track at relative, negative, minus negative 104 kilometer per hour. Negative kasi nga, pa-south siya. Okay. So, ang mangyayari dyan is magiging 88 minus negative 104. 192. So, positive naman to. Okay. Yan naman yung velocity mo with relative to the track. Okay. Now, let us see how do the relative velocities change after you and the track pass each other. Okay. Paano naman kapag nagkabaliktad na, nagkapantay na kayo, ganyan. Pass each other. Yan. Ito ka na, and then, ito na si, subukan natin yung, how do the relative velocities change after you and the track pass each other. Okay. So, subukan natin na velocity of the truck with regards to E, okay, equals velocity of the truck with regards to U plus velocity of the your velocity with regards to the stationary observer. Tas ang hahanapin natin is ito. Okay. So, pag ganyan, parehas lang kasi going north ka pa din at yung truck is going south. So, walang changes. Same lang siya. Okay? Treat this as one-dimensional problem. So, yun lang. So, let's proceed to the next example. Ayan. An airplane's compass indicates that it is headed due north and its airspeed indicator shows that it is moving through the air at 240 km per hour. If there is a 100 km per hour wind from west to east, what is the velocity of the airplane? So, halimbawa, ito si airplane. Sabi niya, ang airplane ay papuntang norte. Ayan. At 240 km per hour. However, merong wind na papunta dito. West to east, so 100 km per hour. So, malamang si airplane, hindi niya madediretso to kasi merong resistance. So, ang mangyari, ang velocity ni airplane pa ganito. Andito na si airplane, okay? What is the velocity of the airplane relative to the earth? Okay? So, velocity of the airplane relative to the earth equals velocity of the airplane relative to airplane tsaka wind. Sige. Airplane tsaka wind. Okay. Yan. Relative to the other particle plus velocity of the wind relative to the earth. Okay. So, ganyan siya. Okay. So, ito yung hinahanap. So, velocity of the airplane with respect to the wind is 240 km per hour. Okay. Kasi sabi niya is moving through the air at 240 km. Okay. Plus velocity of the air or the wind is 100 kilometer per hour. Okay. So, yan. Ngayon, kung titignan natin, ito, ang direction niya is pa-north. Ito, ang direction niya is pa-east. So, ito is kung i-vector natin, okay, kung i-vector type natin siya, yung 100 km per hour, ito yung I natin kasi horizontal siya, plus 240 km per hour. Ito yung J natin, 'di ba? So, makukuha natin si velocity ng air with respect to the earth as 100 squared plus 240 squared, 'di ba? Kasi naging vector siya eh. So, mangyari dyan is 100 squared plus 240 squared. Yan. So, ang velocity pala ni airplane is 260. Okay. 260 kilometer per hour. Kung napansin nyo guys, hindi ko siya mai-add kasi 'di ba kung ito yung susundin nating formula, hindi natin siya mai-add kasi magkaiba sila ng direction. Ito pa ganyan, itong wind pa ganito. So hindi sila magkaparehas ng component. So kailangan natin siya gamitan as vectors, okay? So yun yung difference. Yung kanina kasi parehas sila ng orientation, parehas na pa vertical. Etong isa is yung isa pa vertical, yung isa pa horizontal. Okay? So, ito na yung final answer dyan. So, that ends our discussion for this video. I hope you've learned a lot and thank you. God bless.